Hi everybody and welcome to this video. In this video we're having a look at question 6 of paper 1 of the 2020 GDE preliminary paper. So the approach for this is first I'd like you to try the questions by yourself and use this to mark it. If you have not gone over your functions, please go through our function series before attempting past paper questions. If you find that you have not answered this well enough, then please go through the work once again of the functions and make sure you understand it and then reattempt it. Okay, so let us start. Sorry, I'm just trying to put the mark allocation. So here it is, we have a sketch of a parabola and they've indicated the turning point, which is A2 and 3, and the y-intercept B0 and 5. And then it says show that the equation F can be written as that. So because we have the turning point, it makes sense for us to start. So we know that the turning point is 2 and 3. It makes sense for us to start with the turning point format, which is our equation in that format is A times X minus P squared plus Q. So because this here gives us the P value and this here gives us the Q value, which we can then just substitute. So substituting that in, we get that f of x is equal to a x minus 2. Remember to change the sign from the turning point to the x coordinate, plus q, which is 3, it stays the same. So that's our equation at the moment, just by substituting in the turning point. Once we've got substituted the turning point, we only have one unknown. We only don't know what's a. And to solve for one unknown, we need just one other point that lies on the graph. So looking at the graph and the information that they've given us, we can see that B is a point that lies on the graph. So we can substitute B, which is the y-intercept 0, 5, into F. Okay, so in the place of y, we're going to put 5. A is what we're solving for. In the place of x, we're going to put 0. And then we're going to solve for a. So this is 5 is equal to a times 4 plus 3. Take that 3 over. We get 2 is equal to 4a. And then finally, we divide both sides by 4 and we get a is a half. Okay, so then just substituting that back in, what we then have is our equation is f of x is equal to a half x minus 2 squared plus 3. But now if we look at the equation that they've given us, it's not in the form that they've asked us. This is in standard form. How do we get it from the form that we have into standard form? We simply multiply it out. So x minus 2 squared is x squared minus 4x plus 4 plus 3. And then we distribute that a half. So a half x minus 2x plus 2 plus 3, and then we simplify to get a half x squared minus 2x plus 5. And then what we've seen there is then that is the equation that they would like us to get. Okay, so the trick to that part was really to see that we were given the turning point, and if we're given the turning point, it makes the most sense to use the turning point format of the parabola's equation, because then we know we fill in 2 of the unknowns and we have 1 more left to solve for. Okay, even if you are unable to solve for the first one, 6.1, for whatever reason, it doesn't stop you from doing the rest of the equation, because now you know what is the correct equation. So it says without calculating the discriminant, given an appropriate reason whether the discriminant of f is positive, negative, or 0. So the discriminant is delta, that which is b squared minus 4ac. It tells us whether our roots are real, rational, or non-real. And if you remember, if you watch the nature of the roots video, and if you forgot this, please revise that this here has to do with the x-intercepts. So if we have real roots, if we have real unequal roots, so if the determinant is positive, then what we have is 2 x-intercepts. If we have equal roots, equal real roots, then we have 1 x-intercept. If we have non-real roots, non-real roots, then there's no x-intercept. Please review that video before this. So now they're telling us we shouldn't calculate it. So remember, this year would be if delta was positive, this year is if the discriminant is equal to 0, and this year is if it's negative. But they said we shouldn't calculate it and we should tell that. But we have the image of the graph plotted next to us. So we can see, does it have two x-intercepts? Because then we know that the discriminant is positive. Does it have one x-intercept? Because then we know the discriminant is 0. Does it have no x-intercept? Because then we know the discriminant is negative. Now, if we look at the case, we see that it has no x-intercept, which means your discriminant is negative. Okay. So then the next question says, use the equation to determine the values k for which the graph has real and unequal roots. So us saying it's equal to k, and then solving this, if we take over that k, so let's just say, so if we take a half x squared minus 2x plus 5 minus k, we want it to have two x-intercepts, so we want so this year, okay, is equal to 0. This year is seen as how many units should we shift it up or down. So a plus or minus k can be seen as how many units should we shift it up or down. Now, if we shift it, okay, we know the y coordinate as is 3. If we shift it 1 unit down, it will be 2. There still won't be any x-intercepts. If we shift it 2 units down, it will still not have any x-intercepts. If we shift it 3 units down, then we're exactly on the x-axis, and we have 1 intercept. Here they want to know, when does it have real and unequal roots? So we have to go even lower than that. So if we shift it any more than 3 units down, it's going to then start to have 2 x-intercepts. So k needs to be greater than 3, because that's shifting it down. So if we shift it more than 3 units down, it will have 2 x-intercepts. So real and unequal roots, that means 2 x-intercepts. So how will we get it if we, and then like I said, if you take this over, it's asking, to the other side, it's asking yourself, how many units should you shift it down so that you have 2 x-intercepts? And if we shift it 1, we won't have any x, 2, we won't have any x-intercepts. If we shift it exactly 3 units down, it will have 1 x-intercept, which will mean equal roots. And then if we shift it any more than 3 units down, it will start to have 2 x-intercepts. Then the last one is the parabola is shifted until the new y-intercept is the origin. Determine the equation of the new parabola. So we want to know how many units did they shift it down. So it says the new y-intercept is the origin. So if they had to shift it 1, 2, 3, 4, 5 units down, they shifted it 5 units down. So we're going to have to minus 5 from our equation. So we have that shifting it 5 units down would mean the new equation is f of x minus 5. How do we know we're shifting it 5 units down? Because that's what will take the y-intercept to 0, 0. Now, f of x, we already know the equation is a half x squared minus 2x plus 5. And then we say minus 5. So plus 5. This is the equation of f. And then that's the shifting us down. And if we simplify it, then the equation of the new graph is just a half x minus 2x. Did they say what we should call it? No. So the new parabola that is shifted 5 units down will have that. So this question here was really on your understanding of the shifts and the placement of those things in your graph. If you have not understood it, please go and watch the videos on interpreting functions before continuing. Thank you for watching, and watch the rest of the series and subscribe. Bye.